Uh, Whoever made this paper is evil. That's a nice way of putting it. From a point on a plane hillside of inclination alpha to the horizontal. So alpha to the horizontal, and we are here. And it's projected at a right angle to the plane, so we're projecting at a right angle to the plane, and the particle subsequently strikes the horizontal ground at C. The distances from the foot of the hill to the point of impact on the ground are each h. Okay, grand. So its point of impact to the foot of the hill is h, and the distance it travelled, so the point of projection down to here is also h. Okay, that's good to know. Okay, show that 2v squared, which is 2v squared, is gh cotan. Now, cotan, I don't know what this man is thinking, but look, cotan is 1 over tan alpha over 2. Okay, we can all agree with that much. Okay. Now, let's have a look at this, okay? Now I'm trying to picture this in my head. It's almost as if we're throwing it on an invisible wedge and it lands like that. That'd be more my style, where I can find like that's more similar to the questions I've done in the past, where it'd be like this and I can find out. So imagine I redo this diagram where it's like this. Okay, and you're throwing it down the hill. It feels a bit more like that to me. Is sort of the way I'd be inclined to do it. Once again, an unusual question. Just lots of curveballs being thrown in here, which is quite difficult to say the least. So, if I was to do this sort of like, if I was to try to redo this question in a certain way, and I'm trying to get like an angle of projection from it. So this isn't 90 degrees anymore to me. This is some angle, we'll call this beta. Okay, so this would be 180 minus alpha. This is an isosceles triangle because the two red sides are the same as each other. So yeah, I wouldn't have got this in a test if I'm being honest, so it's good to get this. So we'll call this angle x and this angle x. So 180 degrees, which is the entire triangle, is equal to x plus 180 minus alpha. 2x equals alpha. X equals alpha over 2. So in a way, we've redone this question that it's the angle of our new plane is alpha over 2, and we have a we're throwing it down the hill at a certain angle. Now this angle, I haven't really found what it is yet. Okay, it could be, we'll just call it beta, and beta will not be in our answer because you can see that B is not here at all. Okay, and it's speed v, so speed v is okay, and we have a gravity triangle, which I'll do in green in a second. So our gravity triangle is in green. This is the thing about specialising in questions. You just need to learn every trick in the book possible. And this for me, despite teaching as long as I have, this is a new trick. Just doing past mock papers in every question, it helps. Okay, so this is gravity, and this will be g cos alpha over 2. This will be g sine alpha over 2. And there's my alpha over 2 that I was looking for so badly. Still not sure where my beta is going to go. We'll figure that out later. Okay, so let's break up beta into the thrown angles. So beta here, which we'll do in red. So you have phi cos b and phi sin b. Just after figuring out what b is. See all this here? Everybody see all this here, this mess here of humanity? That's a straight angle. So there's a straight angle between, I'll redraw this. So there's a straight angle between x, b, and then the other 90 degrees when you continue it on. So that's 90. That's beta. That's alpha minus 2. All equals 180. So 180 equals 90 plus alpha over 2 plus beta. So therefore it's going to be 90 minus alpha over 2 equals beta. So I'll be inclined to use that later on. Okay. So here's the fun thing about this. This is like somebody put all the worst questions possible in one test. But look, these things have happened before, so it's good that you know this, right? So imagine, for argument's sake, this is 90 degrees. That's alpha minus 2. And that's 90 minus alpha over 2. Okay? You can sort of interchange it and just give these random letters like x, y, and z. Alright? Sine alpha over 2 is, sorry, I won't use z because it looks too much like the other letters. Call it t. So sine alpha over 2 is y over x. No bother. Cos alpha over 2 is t over x. Okay? And then sine 90 minus alpha over 2, which is using this angle here, is t over x. And cos 90 minus alpha over 2 is y over x. So you can see that the sines and the cos's are interchanged, like so. Okay? So what that basically means is sine beta is the same as cos alpha over 2. Cos beta is the same as sine alpha over 2. And that there has created a shortcut for getting rid of beta, which is very handy. Okay, so this is a downhill throw. So let's get at it. Alright, phi x is phi cos b, because it's going downhill, and it's being added, the acceleration's been added, so then it's a half. Now it's this one here, it's g sine alpha over 2. Now phi cos b, as we discussed earlier, is actually phi sine alpha over 2. Which is handy. Now, Vy, which is V sine B, and as discussed earlier, sine B is the same as cos alpha over 2. Now, a half G, oh sorry, I'm so wrong with that last part. It's U plus AT. So, excuse me, I got that wrong. It's not a half. It's GT sine alpha over 2. And this one here is minus GT. Now we're talking about cos because it's going downwards. GT cos alpha over 2. And then we're going to get the SX equation, which is Vt sine alpha over 2 plus a half GT squared sine alpha over 2. And Sy, which is Vt cos alpha over 2 plus, minus G half GT squared cos alpha over 2. Now, what remains is, I haven't used H anywhere. So the way H is in the answer. Now, how do I integrate in the H? Well, it could be something to do with the range. I'm trying to figure out a way to, we could use the sine rule to, so see this is the range. The range is this one here. I'm thinking we're going to use the range. The range is this, it was a terrible color today. See this yellow part here? Okay, that's the range all day long. And if what I do next is, if I do this, I'm thinking something like this. I'm thinking, I should really stop winging these videos. I'm thinking something like this: sine 180 minus alpha. So we'll call this range, or range over sine 180 minus alpha is the same as h over sine x. And we all know that sine x is sine alpha over 2. Okay. Now, I think our next big trick is sine 180 minus alpha is actually the same thing as sine alpha. So an example is sine 130 degrees equals sine 50, because it's they're the same. 180 minus an angle is the same as the original angle. So same thing as sine 120 equals sine 60. So sine 180 take away alpha equals sine alpha. Now this is really going hard on all the information. Now that sine alpha, I'm not too happy about it. I'll tell you why in a second. You'll see there's only half angles in the answer, no full angles. So I reckon I'm going to have to get rid of that sooner or later. So either way, the R value, the range, is H sine alpha over sine alpha over 2. Now, actually you do have a way of getting rid of that. And this is like trigonometry 101 here. It's killer. Sine, remember sine 2x equals 2 sine x cos x. Okay? Imagine x is alpha over 2. Right? So this becomes sine, and 2x would be alpha. So sine alpha is 2 sine alpha over 2 cos alpha over 2. The alpha's over 2's, so I'm changing this into 2h sine alpha over 2 cos alpha over 2. By the way, no way I could do well in this exam. The alpha over 2's cancel, and what we get is 2h cos alpha over 2, right, which is insane. Now that I've established what the range is, I think that's where I'm going to go next. The range is Sy equals 0 for the time of flight. So Sy equals 0. Okay? And what this means is that Vt cos alpha over 2 minus a half, equals a half gt squared cos alpha over 2. Well, this is interesting because the two of them are going to cancel, and the t is going to cancel, and I'm going to get t equals 2v over g, which is in all types of interesting. Now, when I insert this time of flight into the Sx formula, I'll find the range. So range, which is an Sx value, equals v times 2v over g. So I wasn't expecting that to go down at all. And then sine alpha over 2, and then plus a half g. Now t squared is 4v squared over g squared, sine alpha over 2. Range therefore is what's that, 2v squared over g sine alpha over 2. Half of that is another 2, so plus another 2v squared over g sine alpha over 2. Say that 5 times fast. And then 4v squared over g sine alpha over 2 equals r. Now, where is r? There it is. R is 2h cos alpha over 2. Two h cos alpha over 2. Now what am I being asked to do here? I need to get 2v squared on its own. No bother. No bother, no bother. Actually, I have an idea, lads. I have a very good idea. I think we're going to get this out somehow. So ask me how or why. I'm going to bring this cos alpha over 2 underneath. And as we all know, that will make tan alpha over 2. So I'm going to get 2h equals 4v squared over g tan alpha over 2. Cancel the 2, so that's 2v squared on its own. Bring up the g, so it's going to be gh. V squared on its own is gh tan alpha over 2, and 1 over tan alpha over 2 is cotan alpha over 2. So gh cotan alpha over 2 equals 2v squared. Every ounce of mathematical ability I have is probably used there at one point or another. Yeah, that's insane. If the speed just before impact is double the speed of projection, find the value of a. Oh dear God, this man is evil. Now remember, it's speed. It's not even. So speed would be 2v. It's not even. Oh my God, find the value of alpha. Alright, get this. Now this is grim as well. You get your time of flight, your TOF, and you lob it into your Vx and your Vy. So this part here, this is awful. I can't get over how awful this is. Alright, so here's what you do. You put Vx equals V sine alpha over 2, and then you do GT, so G times 2V over G sine alpha over 2. Our Vx is going to be, the G's cancel, so I think I'm going to get 3V a sec there. I think I'm going to get, so that's 2V sine alpha, so I think I'm going to get 3V sine alpha over 2. Alright, and then we're going to get Vy, which is V cos alpha over 2 minus GT, so once again minus G, and T is 2V over G cos alpha over 2. Now that's Vy is usually negative, so Vy is what's it, minus V cos alpha over 2. Now imagine this scenario, back to our original diagram. Imagine you're dropping downwards, alright, and you're dropping downwards for argument's sake 3 across and 4 down. 3 across, 4 down. You're after the hypotenuse. The hypotenuse is the speed. Okay? So in this condition, it's essentially this. It's Vy, Vx, and the hypotenuse is 2V. So 2V, 2B squared equals Vx, 2B squared, plus Vy, 2B squared. So let's see how I'm going to green out. I'm going to finish this off. So 4V squared, no bother. Square Vx, you get 9V squared sine squared alpha over 2. Square Vy squared, and you get Vy squared is V squared cos squared alpha over 2. Okay, all the V squareds cancel, which means they are obsolete and gone. Now here's what I'm thinking. The V squareds are gone, and what I'm thinking is if we do 4 equals, now see this 9 sine squared, if I change that into 8 sine squared alpha over 2, then I do another sine squared alpha over 2 plus cos squared alpha over 2. Now I think I may have made a mistake, so I'm going to go looking for it. Hilarious part of all this is I'm looking at the solutions and I still think I'm wrong even though I'm right. So either way, sine squared any angle plus cos squared any angle is 1. Bring that over to the other side, you get 3 equals 8 sine squared alpha over 2 divided 3 over 8. Whoever made this did not want anybody to use their exam. This has taken me 25 minutes already. That's a full question. Okay, square root alpha over 2 will equal sine inverse that, 37.76 multiplied by 2, alpha equals 75.52, alpha equals 76 degrees. I'm so sorry.